Okay, so let's show this same procedure at work when it comes to something like y equals 1/2 cosine of x. And again, for reference, I'm putting our cosine table that we were referencing before, and we're going to use that to help us draw our graph. So in this case, what would we say? Well, our amplitude is always equal to the absolute value of the number a that's multiplied in front of the sine or cosine function. So in this case, we're going to say our amplitude is 1/2. The period, again, has not changed. The period, we didn't do anything to x. We're just saying that the period starts at 0, ends at 2 pi for one full rotation. So we're going to say that is our period right here, 2 pi. And the basic function that never changes. The domain, that'll be all real numbers. The domain would be negative infinity to positive infinity in interval notation. And then finally the range. Well, the range is based on the amplitude. And the way we get the range is to take our value of our amplitude and go from its negative to its positive value unless we've had some sort of shift. So right here, we can take that to be negative 1/2 to positive 1/2. Okay, so what do we do right here? Well, in this case, we're going to be changing our graph by getting y equals 1/2 times all the cosine of x values that we had before. So again, imagine that we're going to take our y values and multiply each of them by 1/2. What are the new y values that we get? Well, 1/2 times 1, 1/2 times 0, 1/2 times negative 1, 1/2 times 0, 1/2 times 1. So here is my basic points for my graph of cosine. So what am I going to do? Well, let's go ahead and let's get a picture of our function. Here's our x-axis. Here's our y-axis. We're going to go from 0 to 2 pi. So let's mark off our x-axis. Here's pi over 2. Here's 0. Here's pi. Here's 3 pi over 2. And here's 2 pi. If we're to continue on in this vein, 5 pi over 2, 3 pi, 7 pi over 2, and then 4 pi would be next. So for one full cycle right here, let's see what's going to happen at least. 2, let's use negative pi over 2. So okay, our y value goes from 0 to 1/2. So let's see, let's put let's see, 1, 2, 3, 4, 5, 6. Let's put 1 here this time, and let's put 1/2 here. And this would be negative 1/2. And we're going to make this negative 1 way down here. So what does it look like? In our function, y equals 1/2 cosine of x. At 0, y is equal to 1/2 this time. At pi over 2, y is equal to 0. At pi, y is equal to negative 1/2. 3 pi over 2, we're back to 0. 2 pi, we're back to positive 1/2. And then we would just continue following this pattern all the way around along our graph until we had one full cycle. So one full cycle, here's our basic cycle, starts at 1/2, curves downward, right? It's not a straight line, right? Don't make this post-modern cubist art here. Goes in a curve towards this last point, because remember, it's not decreasing in a steady manner. It curls down. So we're going to go up here from negative 1/2 to 0 at 3 pi over 2. 3 pi over 2, 0 to 2 pi. That is one basic cycle of the function. If we're asked for more, we're just going to simply repeat that same pattern over and over again. So we'll pass through each of these points in turn, just following that same sinusoidal pattern all the way around. Here's 2 full cycles almost. And if we looked at it, it looks amazingly like the sine function, only shifted over. Well, we're going to explore that fact a little bit later on. But here is one basic cycle. This would be one full period right here of 2 pi. Okay. For comparison's sake, if we were looking at the cosine function that we started out with before, you see that our y equals 1 times cosine of x would be passing through these points right here. So in effect, what we've done is we've compressed the graph towards the x-axis directly. So that's what that would look like within one cycle of cosine. Here's a bit more of it. But you get an idea of what that idea of compression means to us. So our graph right here in green, that's the one that we want. Okay, more stuff to come.